find a unit vector perpendicular to u equal to 1, 2, 1 and v equal to 2, 1, 1. Our candidate for a perpendicular vector is going to be the cross product. So let's take a look at our two definitions of the cross product. First, the geometric definition. Here, we're going to need three items. So we're going to take u cross with v. That's going to be defined by the following three properties. First, its length. The length is going to be given by the area of the parallelogram spanned by u and v. So numerically, that's going to be the length of u times the length of v times the sine of the angle between u and v. Next, our cross is going to be perpendicular to both u and v. So if you take 1 and 2, what do you note? If I take u and v, it's going to give me a plane. So if we take the vector perpendicular to that plane, all right, we're going to have a line. And then if I cut it off at a given length, we're going to have two choices for our vector for the cross. The way I decide which one to go with, we're going to use the right-hand rule. So that means if I put u on my pointer finger, v on my middle finger, and we curl, then our cross is going to point in the direction of my thumb. So those three items give us our cross product. Now, we're mostly interested in property 2. We want a vector perpendicular to u and v, and so the cross product fits that bill. In the second definition, we get the arithmetic to calculate the cross product when we're given two vectors numerically. So here, we'll put ijk on top, we'll load in u, we'll load in v. That gives me a 3 by 3 matrix. I put it next to itself. Then our rule is multiply down the first 3 diagonals, multiply down the next 3 diagonals in the left direction, then take their difference. That gives us our cross. Now note you probably taught this slightly differently, where I would take I and then do the cross product here, take the j, cross here and put a minus sign in, take the k, then take the cross multiplication there. Going to give you the same exact answer. This way, I think it's a little bit easier to manipulate. So in this case, what do we have? 2i, 2j, k, minus I, minus j, minus 4k gives me I plus j minus 3k, or the vector 1, 1 minus 3. Now, we're asked for a unit vector, so we're not done yet. I'm just going to divide by the length of our vector here. So what do we get? Get 1 squared plus 1 squared plus 3 squared. Square root gives me square root of 11. We divide by square root of 11. That gives us our vector w, 1 over square root of 11, 1 over square root of 11, minus 3 over square root of 11. If, when you did this, you used v cross u instead of u cross v, things change by a minus sign. So we actually have another solution, which is just going to be given by minus w. All right, we should check our work. So two things we want to check. We want to check unit and perpendicular to u and v. Unit, you just take the sum of the squares of your entries. You'll get 1 squared plus 1 squared plus 9 gives me 11 on top. And then I'm just going to have square root of 11 squared on the bottom, which is another 11. So 11 over 11 gives me a 1. So we have a unit vector. Perpendicular. So let's try u perpendicular to w. So we use the dot product. So two vectors are perpendicular if their dot is equal to 0 and vice versa. So what do? I'm going to take 1, 2, 1, dot product with 1 over square root of 11, 1 over square root of 11 minus 3 square root of 11. So we'll get a 1 times first entry, 2 times the second entry, 1 times the third entry. So along the top I have 1 plus 2 minus 3, so I get a 0. So u and w are definitely perpendicular. I'll leave the check for v and w to you.